Control of body pH. I want to start by showing you just how important the control of body pH is by illustrating what can happen if the pH dramatically changes. Now, the normal bodily pH is 7.4. Acidosis occurs when the pH drops to 7.35 or below. Alkalosis occurs when the pH rises to 7.45 or above. Mild acidosis depresses the central nervous system and causes such symptoms as confusion, disorientation, and coma. On the other hand, mild alkalosis makes the nervous system hyperexcitable. Nerves fire spontaneously, and there's overstimulation of skeletal muscles. Severe acidosis or alkalosis is lethal. Now, there are three main regulatory mechanisms. The first of these is chemical buffers, and these respond within a few microseconds. The second is the brainstem respiratory centres, or the respiratory system, and this works within 1 to 3 minutes. And finally, there's the renal mechanisms, and these offer long-term regulation, which occurs over several hours, or perhaps as much as a day. Now, because of time constraints, I'm just going to concentrate on the respiratory centre. Now, I want to introduce you to a very important equation, which is shown on the right-hand side. CO2 plus H2O goes to H2CO3, which then breaks down into H plus and HCO3. In other words, carbon dioxide plus water goes to carbonic acid, which is then broken down into hydrogen ions and into bicarbonate. Now, if we have a rise in the plasma's carbon dioxide concentration, as can happen with hypoventilation, then this pushes the reaction in the downwards direction and will result in an increase in the concentration of hydrogen ions. Now, this change or increase in plasma carbon dioxide concentration is detected by the central chemoreceptors. These are located in the ventral medulla. The increase in plasma hydrogen ion concentration is detected by the carotid and aortic chemoreceptors. These are called the peripheral chemoreceptors. Both of these groups of chemoreceptors fire to the respiratory control centres in the medulla. The medulla in turn sends out action potentials in somatic motor neurons to the muscles of ventilation. The result of this is an increase in the rate and depth of breathing. The effect of an increase in the rate and depth of breathing is that it will expire more CO2. And with that expiration of CO2, if we look again at this equation on the right-hand side, we can see that this is now pushed in the upwards direction, and therefore getting rid of the excess hydrogen ions. Now, there's also a negative feedback control here. So, having expired the CO2, the plasma concentration of CO2 is going to decrease. This is detected by the central chemoreceptors, and it then inhibits their firing. The decrease in plasma hydrogen ion concentration will be detected by the carotid and aortic chemoreceptors, and this will also decrease their firing. This decrease in firing from the chemoreceptors is detected in the respiratory control centre, which also decreases its firing. So you have decreased action potentials, decreased stimulation of the muscles of ventilation, and a decrease in the rate and depth of breathing. Hence we have this circulatory mechanism of control. Thank you for your attention.